Hey everybody, Brandon with FastDataScience.ai here, and this is another episode of Drumroll. Please, one day I will have cool sound effects. You guessed it, this week in AI. The show where I bring you all of the latest news articles and headlines that hit my inbox, are organized with a little data science of my own, and then teed up based off of all of the different representative articles in that organization that I think are super cool, things I want to learn more about. I wrap all that up into a low budget PowerPoint presentation so I can share it with you. So let's go ahead and get after it. Today is March 18th, 2022. And do you know what that means? That means that today is the day after St. Patrick's Day. That's right, the day after St. Patrick's Day. And clearly, I am still wearing green. Now, I'm not hungover, but maybe my shirt is. Yeah, whatever. Let's get on with it. What did we find in the inbox this week? We found 80 articles, and those articles were actually organized into a more granular topic solution than I have seen in past shows. We actually organized these 80 articles into 7 different topic areas. Now, I know what you're thinking. You're looking at this dendrogram and you're going, wait a second, Brandon. I would actually argue that a 3 topic solution is more appropriate for these data. I might agree with you if I was only looking at the dendrogram, but I actually peered into the 7 topic solution and all the different articles that were organized around those topics. And for me, it was meaningful. And I thought I pulled out some really interesting topic categories that I was happy to see. Certainly, there are some relationships across these topics, and hence the hierarchy that groups them together. But I decided to share the 7 topic solution with you, talk about some of the articles that I pulled out of these topics that I think were super cool, super interesting. So not surprisingly, the biggest topic grouper, as we have seen in the past, is education. But more interestingly were some of the other groupers. Moral artificial intelligence was another area that popped up, and I tackle one of those articles actually in this show. Mistaken artificial intelligence, that is all the mistakes that we might make as data scientists, machine learning engineers, or artificial intelligence engineers, as well as some of the mistakes that our artificial intelligence solutions might make. So we'll look at both, actually. One's obviously a little bit more closely related to morality. The other's a little bit more closely related to professions. So we'll talk about both. Tech analogies. That's a new one. That's definitely a new one. Now, wait a second. Let me ask you a question. What do Yaks and data scientists have to do with each other? Okay, think about that. We're going to come back to that one because I definitely learned something new, and that's the one that caught my eye this week. Then we had the United States of Artificial Intelligence, which was really just a whole bunch of headlines that said the state of AI or AI in the US or something like that. So I grouped them. Artificial intelligent applications, again, another common topic. Boring, moving on. The cool topic that I also thought was an interesting grouper, showed me that maybe this solution does kind of work, even on small data, was events. So we actually grouped a bunch of the different articles based off of their discussion of upcoming events. So I thought that that was awesome. A little bit of affirmation to some of the decisions I've made in building the analytics that support this show. Okay, well, let's go ahead and jump in and talk about our first article, 9 mistakes data scientists must avoid. From early career data to senior level professionals. These are the most common mistakes data scientists make and how to avoid them. I will give you my impression. I thought the article identified some really good mistakes. These are common and in my experience, indeed, are mistakes that data scientists and data science leaders make, but probably had some different opinions on how to correct them. So what were the 9 mistakes that are common? Why do I care about this article? Well, here are the 9 mistakes. Not having a plan. Duh. Number 2, choosing the wrong visualizations. Visualizations. That's a tough word. Choosing the wrong visualizations. That's a tough one, actually. That's a tough mistake to make, and it's a common one, and it's a tough one to solve for, even more importantly. Failing to consider bias in the data. This is also a really important point. We often forget that our data are biased. If you've been following me this week, you know that I'm doing a March Madness challenge, a predictive analytics challenge, and I found some bias in the data that I put together. I'll share that on a video later, but the importance is to really recognize that yes, we do need to be aware of the different sources of bias that can enter in to our model building process and create outcomes that are also biased. So, or and in some cases, right, scale that bias so that it affects lots of people. Neglecting to optimize the model for your data. Indeed, we want to train our model on the data that is closest to the data that we're going to use the model with in production. Another kind of no duh, but you'd be surprised at how often that doesn't happen. People will take pre-trained models and apply them and realize that they don't apply quite so nicely to their specific use case because they were trained on different data. So really good point there. Focusing on accuracy over performance. Indeed, both are important. We definitely want highly accurate models, but in addition, we also want to make sure that those models scale, right? So if we develop some really sophisticated, complex, GPU-trained deep learning model, it may not scale very well if we don't have a whole cluster of computers, with GPUs enabled, right? So we got to think about those things. Ignoring that correlation doesn't equal causation. If you hear me say one thing, it's this. All data science models are correlation, not causation. Keep that in mind. We're not conducting experiments in data science to build our models. No, we're using measures and metrics available to us to try and predict some future outcome. We might use measures and metrics that are informed by what we know about cause and effect, but there is by no means a relationship between our data science models, their sophistication, and whether or not they actually give us some indication of cause. Okay, moving on. Reusing implementations, okay, that's true, sort of related to neglecting to optimize a model for your given data. Choosing the wrong tools, another no duh. Of course, choose the right tools for the use case. They don't always have to be the most cutting edge, most sophisticated data science tools. And then finally, forgetting the business. This is super fundamental. Never forget the use case that drives the reason for building what you're building. Okay, the closer you are to the business case, the stronger the solution will be, the more adoption it will get, and the more people you have the potential to impact. Okay, let's go ahead and move on from this article. All right, the next article. This is all about moral artificial intelligence issues and all the issues that artificial intelligence technologies are raising from a morality perspective. Artificial intelligence in the future of war. With artificial intelligence, decisions are made far too quickly for humans to correct them. And not only that, decisions are becoming more and more automated. So why do I care about this? Who shouldn't care about this? Everybody should care about this. Is all fair in AI and war? Probably not, right? This article really kind of tackles this question, really helps us to understand and put in perspective what humanless decisions are. I found it really insightful as it kind of related sort of how we've used humanless decisions in the past, sort of dumb technology, if you will, like through landmines, which are humanless, right? They kill people without a human interacting to make the decision to kill that specific person. So kind of interesting there, but the article goes in to talk about how that has become more sophisticated with the inclusion of artificial intelligence. We can make more complex decisions with artificial intelligence and automating the decision to shoot someone, for example. So this has tremendous societal, political, economic consequence. And another really insightful thing that I got from this article is the idea that there is political motivation to continue to automate war because the fallout from robots dying is a lot easier to muster than the fallout from humans dying. I mean, think of it, right? I pulled this quote out of the article. There would be no footage of captured soldiers or singed corpses of pilots on their knees in a snowy field begging for mercy. Mama, why? This is why warfare will likely continue to become more remote and more faceless. So this is something that all of us should be concerned about, has tremendous policy implications, and this article really does a nice job of tackling this question and looking into the potential consequences, and also the reality that these things are coming. They are coming, and it is going to be important for us to have some influence over the decisions that are made from a political perspective, most importantly. Okay, let's go ahead and move on. On a related note, I pulled this article in, Scary Flaws in Machines That Make Government Decisions. So sort of related to both moral AI, but also mistakes in AI. This article was really cool because, why do I care? It actually teed up some really interesting consequences of when algorithms decide what's the fallout, what's the human fallout of that. By and large, we want our algorithms to be accurate, and so we leverage them to help automate decision making. But the problem with that is we forget the cases where the model or the algorithm is not accurate. A model that's 99% accurate will be wrong one time out of 100, right? So it's important to keep that in mind as we think about how we deploy these things whenever they're having real human impact. So here are two examples from the article that I thought were really, really enlightening. A man in Michigan was wrongly accused of unemployment insurance fraud, and in the 2 years it took to clear the charges, he had to file for bankruptcy. That is all due to an algorithm that was used to identify fraud in insurance claims. Number two, in Illinois, a child welfare algorithm overestimated the number of children at high chance of death, while at the same time, it didn't identify several high-profile deaths. Again, another algorithm that was being leveraged on the data that they had available to identify children at risk, and it missed some really important, and when they looked at the data, they weren't just important indicators, they were indicators that really questioned who the heck built the model in the first place if you didn't take those into account. Like how many times a child has been abused and that's been recorded by the police, right? You would think that's a pretty good indicator of risk. Well, apparently this algorithm missed it. The point here is we need to stay in front of all of these algorithms and how they're being deployed, because they have real consequences like this. Now, I like to believe that by and large, the effect for most is positive, but there are these cases for individuals that still matter and that will still be impacted. And so we need to have these questions at the top of our mind when we're deploying our algorithms in the same way to make automated decisions for us. Okay. All right. So what caught my eye this week? Okay. So let's go back to the yak question. What do yaks and data scientists have in common? Well, let me talk about that, because this article hit my inbox. Yak Shaving and Success in Enterprise Data Analytics. Okay, so I learned something new in this article. Yak shaving, apparently, I did not know this, is old jargon that programmers used to use to describe this. Yak shaving is a programming lingo for the seemingly endless series of small tasks that have to be completed before the next step in a project can move forward. This was coined by somebody named Seth Godin, or at least written at length by a programmer named Seth Godin. And what's really interesting about this is, as I read this yak shaving analogy, I was like, oh my gosh, data scientists totally experience this all the time. And so I started to think about, where do data scientists generally experience the yak shaving phenomena? And here's what I came up with. Yak shaving in data science happens whenever we're building features, because there's a never-ending conversation about whether or not we included the right features in our model. If you work in healthcare, as I have, then you know that certainly that's the case, particularly when dealing with lots of different people who have domain expertise in that area. They're constantly asking, yeah, well, did you include this? And did you include that? And that can turn into, now it is maybe my new favorite phrase, a yak shaving expedition. Okay, model tuning is another area where we can tweak and tune and adjust and change our ADA on a boosted model by 0.1 or 0.2. And that model tuning can turn into a yak shaving expedition. And then there's capability creep, right? Has your boss ever said, "Hey, just go ahead and put the AI on it, and let's go ahead and see what happens. We'll get the insight we need." Yeah, well, it doesn't work that way, and that's a spot where you can actually get into a yak shaving expedition because you're constantly searching for different algorithms that help to learn from data when you have no real use case, right? You have no real objective. That's a yak shaving expedition, probably by and large its definition. So the use case that was covered in this article discovered that ultimately we need humans in the loop. That it's really important to make sure that there's a feedback cycle. And what was really fascinating, although the article didn't mention user experience design or human-centered design, they ultimately concluded that human-centered design practices really help to enable data science solutions and also help to get through some of the yak shaving expeditions. The important thing, though, is making sure that you keep the objective at a high level, constantly reminding yourself of which direction you're headed. Okay, so by doing so, you can take the compromises that are needed to avoid shaving too many yaks. So I'll leave you with this quote from Seth Godin that basically just says, "The minute you start walking down a path toward a yak shaving party, I like expedition, he likes party, it's worth making a compromise. Doing it well now is much better than doing it perfectly later." That's what's really important to keep in mind. That's why we need humans in the loop, is because we want to get something delivered that does a good job, evaluate it, observe how it impacts our decision making, and then iterate, right? Update, add, change later, move, but wait until you deploy to be able to see what the impact is. I think conversations with people work the same way. Learning and education works the same way, right? We want to learn something, so we read it or we watch a show about it or whatever, but we really don't learn it until we start to put it into practice. And when we put it into practice, it's not always perfect, right? So what we do is we refine it based off of that experience of putting it into practice. So if I could tell you anything about your data science solutions, put them into practice, but be careful, right? Because they could have some real human impact. So we got to watch for that as well. It's a balance. It is a cost benefit analysis, if you will. So that's what I have for you today on This Week in AI. Sorry, the show's a little bit long, but here are the links. Obviously, I upgraded my recording software, so now I can go over 10 minutes. I won't abuse that in the future, I promise. Again, more to come next week, and I hope all of you have a wonderful weekend. Thank you. Bye, everybody.